Hello, dear students of grade 5. I missed you so much. This is Muhammad Qasim, your science teacher. Welcome back to our online session, my best students in the school. Very well. Today we have two new planets, which are Uranus and Neptune, the last planets in our solar system. Very well. What about Uranus? Of course, you know that it is the seventh planet from the Sun. It is the seventh planet from the Sun, and its most distant planet you can see without telescope, which means it is the last planet you can see with your naked eyes without a telescope, which means Neptune you have to use a telescope to see it. Very well. And it is also a gas giant. So Uranus is a gas giant. With an atmosphere of hydrogen, the atmosphere of Uranus consists of hydrogen, helium, and methane. Hydrogen, helium, and methane. Uranus also is so cold, which transfer the methane into a liquid. The methane is very hard to transfer it into a liquid, but due to the coldness of Uranus, it transfer into a liquid. And by the way, the planet have fuzzy blue-green look. A fuzzy blue-green look. What is the reason of this? Because tiny drops of the liquid methane form a thin cloud that covers the whole planet, giving it this fuzzy blue-green look. Uranus also has rings, such as the other gas giants, and many moons. Unlike the rings of Saturn that you see, the rings of Uranus are dark and hard to see with Earth-based telescope. Even if you are using telescope, you cannot see the rings of Uranus. It cannot be appeared even with using a telescope. So Uranus have dark and hard rings to see. Okay, Uranus also rotate on its side. What? Yes, rotates on its side. As you see here that we have into this shape, if we try to draw an axis, it's gonna be like this. Not the other planets like this or even have incline, but this have a very tilted axis. So it rotates on its side. No one knows why Uranus has this odd tilt, but scientists think that a large object have hit the planet once before, when the solar system was still forming. So what scientists think about Uranus? They think that something big that hit Uranus make it rotates like this. Okay, so scientists think a large object may have hit the planet when the solar system was still forming. This bump may have knocked Uranus onto its side. This may be the reason that Uranus rotates on its side. And now we have a small question here. How might Uranus odd tilt affect its season? And it's a very intelligent question. I want you all to record a video or solve the question and show me the answer. Send me via WhatsApp and so on.
In ancient times, humans studied the night sky and discovered the worlds of Mercury, Venus, Mars, Jupiter, and Saturn. But beyond this realm of knowledge, another world shined brightly, just waiting to be discovered. Uranus is the seventh planet from the Sun. From a distance of about 20 astronomical units, or 20 times the distance between Earth and the Sun, Uranus orbits the star once every 84 Earth years, approximately the length of a human's entire life. This orbit causes each season of Uranus to last that much longer. Theoretically, a human living on Uranus would experience the 4 seasons only once, but each for about 21 years. Partially due to its distance from the Sun, Uranus boasts the coldest temperatures in the solar system. These icy temperatures, dropping as low as negative 370 degrees Fahrenheit, are largely influenced by the planet's composition. At about 4 Earths wide, Uranus has an Earth-sized core made of iron and magnesium silicate. The remainder, approximately 80% of Uranus, is a worldwide ocean of ices made of water, ammonia, and methane, the chemical behind the planet's cool blue color. This icy composition prevents Uranus from emitting much heat compared to other planets, making the blue world the solar system's coldest. In addition to its extreme temperatures and orbit, Uranus has a dramatic orientation. While the other 7 planets spin on their axes like tops, Uranus appears to roll along its equator. The planet is tilted at a near right angle, in which polar regions point toward and away from the Sun rather than upward and downward. This tilt, thought to be the result of Uranus's collision with at least one celestial body, has also affected the orientation of Uranus's 13 rings and 27 known moons. Unlike the rings and moons of other worlds, which orbit their home planets horizontally, those of Uranus orbit in a vertical orientation along the planet's tilted equator, much like a Ferris wheel. Uranus and its many unusual features were a mystery to the ancients, and the planet was actually thought to be a star. But in the late 18th century, astronomer William Herschel discovered that the celestial object was actually a new world. The scientific community debated over what the planet should be called, and eventually chose a name suggested by astronomer Johann Alert Bode. Bode believed that, since Jupiter was the father of the gods, and Saturn was the father of Jupiter, then this new planet should be the father of Saturn, Selous. But rather than following the tradition of using names from ancient Roman religion, Bode instead opted for Selus's ancient Greek equivalent, Uranus. Uranus, the ancient Greek god of the heavens, was then Latinized to be Uranus. To this day, Uranus is still the only planet that veered from tradition with an ancient Greek namesake, a status most fitting for a planet beyond convention.
And now we will talk about Neptune. Neptune is too far away to see without a telescope. We can only see the last planet that we can see with our eyes is Uranus. But Neptune, we need a telescope to see it. It is the 8th planet from the Sun. Astronomers discovered it in 1846, and it takes more than 100 Earth years to rotate around the Sun. Do you believe this? 100 years to complete one revolve around the Sun. Neptune is the smallest of the gas giants. It is the smallest planet in the outer planets, one of the smallest of them that can fit only about 60 Earth. Even it's the smallest, it can fit about 60 Earth in volume, of course. Neptune's atmosphere is like that of Uranus. It has helium, hydrogen, and methane. And Neptune has a bluish color. It looks blue because of the methane in its atmosphere. Neptune also has a lot of storms and bands of clouds such as Jupiter. Storms and bands of clouds such as Jupiter. And it has also 13 moons. The largest of them is Triton. The largest moon of Neptune is Triton, which may be the coldest object in the solar system. The coldest object in the solar system is Triton, one of moons of Neptune. One of Neptune's moons that be the coldest object in our solar system. And now we have a question. He is asking you to compare what is the similar about atmospheres of Uranus and Neptune. It's a very easy question. I also want me to show your answer.
Along the dark edges of the solar system, it floats. Anchored by a star, but barely graced by its warmth, this traveler drifts alone, as deceptively calm and elusive as the deep blue sea. Neptune is the 8th planet from the Sun. At about 30 times the distance between our star and the Earth, or 30 astronomical units, Neptune is the most distant planet in our solar system. This distance creates the longest orbit of the 8 worlds, about 165 years, with the seasons lasting a little over 40 Earth years each. Being so far away from the heat and light of the Sun, Neptune is cold, dark, and icy. At its heart is a solid core about 1.5 times the size of Earth. Making up about 45% of the planet's mass, the core is made of water ice and silicate rock. The rest of the planet is believed to be a hot, pressurized ocean of water, methane, and ammonia ices surrounded by a layer of clouds. These clouds, predominantly made of hydrogen and helium, include traces of methane, which give this ocean world its rich blue color. While the clouds create a cool, calm veneer from afar, up close they are whipped around by the most severe weather in the solar system. Winds on the planet reach speeds of over 1,200 miles per hour, nearly 5 times faster than the strongest winds recorded on Earth. In fact, the winds are so powerful that they break the sound barrier. Drifting high above this windy ice giant is a quiet ecosystem of rings and satellites. 6 rings encircle the planet, with some containing ring arcs, or clusters of dust particles in a ring. Also revolving around the planet are 14 known moons, with the largest called Triton. Named after the son of the ancient Greek sea god, Triton has ice volcanoes and may even contain a subsurface ocean. Much is left to be discovered about Neptune, its rings, and its moons. Only one spacecraft, Voyager 2, has visited these cosmic bodies, but future missions to this mysterious, icy world would have even more stories to tell.
Oh wow, it's a fantastic lesson till now. But how could we discover all of these information? I think of course, by the probes, by the space probes that have been sent to explore the outer planets. They were launched from Florida. The first of them was Pioneer 10 and 11, was launched in 1970s, followed by Voyager 1 and 2. Then Galileo probe explored Jupiter's in great details, and the Cassini mission has sent back a huge amount of information on Saturn. How this happened? They launched a smaller probe named Hygiene, was launched from Cassini mission and was able to land on Saturn's largest moon, Titan. So, how they discovered a lot of information about Saturn? They sent a small probe that called Hygiene from Cassini mission that was able to land on Saturn's largest moons, which is Titan. Very well. Now, here is a question. What information might you like to have sent to you from a space probe? What do you think? The type of the planet, the rocks, the storms, and so on. A lot of information will be sent, of course, because you examine the planet from a small distance. Very well. We have small questions here. Number 7, he's telling you, think about 3 terms that describe characteristics of the inner planets and the outer planets. Use the terms that contrast the inner and the outer planet, which means what is the difference between the inner and the outer planet? 3 characteristics for inner and 3 characteristics for outer. We have also a question here that tells you what are some common characteristics of all planets. So question number 7 asking you to put 3 characteristics for the inner and the outer planets to tell the difference. And here at question 8, he is asking you to tell the similar or the common characteristics between all planets. Very well, this is everything for today. I hope you have enjoyed the lesson. See you next session. Bye.